So in today's class, we are talking about set theory. We're talking about set theory. So from there we move to Venn diagram. So from there we move to Venn diagram. So when we talk about set theory, what are the major things we're actually focusing on? What is set itself? So what is set? I term is that a set is a collection, of related items which are used for specific purpose or which are gathered together for specific reasons. Now, number one, example one, I can call it what? A mathematical set. A mathematical set. Now, mathematical set encompasses what? A compass, a divider, a ruler, how do we call it? A ruler, eraser, and so on and so forth. Now, as we say this, we can as well call grouping numbers too. Let's say all alphabets. You can call it A, B, C, D, E, F, G, H, till you get to what? Till you get to Z. So they are collections of what? Of data. They are collections of related data. They are collections of related items for a specific purposes or for a certain reasons. Now, when we talk about sets, we have two types of sets. We have types of sets. So, one, finite set. Now, finite sets are sets which has definite number of elements or definite elements in that set. Now, we said finite sets are sets which has definite number of elements in that set or definite elements. It might not necessarily be number. So, example of finite sets. So, which means that they are terminatable. They have an end. They will always have what? An end. So, let's say example is what? Or e.g. all vowels. Now, all vowels, you know vowels present in what? In letters. That's what? A, E, I, O, U. And now, sets are enclosed with what? With a curly bracket. That's the law. Sets are enclosed in a curly bracket, not just bracket like this. No, that's not set. Sets are enclosed in what? In a curly bracket. Example, further example, you can say that prime numbers between 1 and 10. Prime numbers between 1 and 10. Now, this prime number is 2. And what are prime numbers? Prime numbers are numbers that are divisible by 1 and itself. They are numbers that are 3 is also there, 5, 7. I know some people might be thinking 9, but 9 is never a prime number because 3 can actually divide what? 9 can be divided by what? By 3. So now note, not all odd numbers, not all odd numbers are prime numbers. But all prime numbers are odd numbers, excluding what? Excluding 2. So not all odd numbers are prime numbers. Just like 9 now. 9 is an odd number but cannot fit in as a prime number. Now, but all prime numbers are odd numbers, excluding 2. It's only 2 that is an even number that fits in to be what? To be a prime number, because it can be divisible by 1 and itself. Are we together? It can only be divisible by 1 and itself. Then we are moving to what? Non-finite sets. Now, non-finite sets are a set of related data, a set which has no definite elements. Are we together? Now, let's take for example, all integers. If you start from 1, if you count to million, you are not still, you've not still what? You've not still put in all the values of integers. Are we together? That's why we said it is non-finite. Are we together? Now, if we talk about all odd numbers, they are what? They are non-finite sets. Because as we are progressing, counting this, counting that, we will not still exhaust them. So that's why we say what? They are non-finite sets. So let's move to, so we are moving to terms used what? In sets. One of the first I would like to talk about is what? A subset. Now, a subset can actually be group of what? Group of elements found in what? In another element. Like, let's say, I said group of elements found in another element. Let's say set A contains counting number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And set B contains odd numbers from 1 to 10. So we'll still do this explaining this with what? With set builders and set notation. I will explain this particularly. So now you have the liberty to what? To write out the odd numbers. That's 1, 3, 5, 7, 9. Now we can say B is what? Is a subset of what? Of A. Are we together? Let me rub this. We can say what? B is what? Is a subset of what? Of A. So that's how subsets work. When we get to universal sets, when we get to complement of sets, and all of that, power sets, we will still explain this. We will still explain, especially power sets, we will still explain this what? This possible subset. Now, number 2 is what? Empty set. Empty set is when you have no element. You have no element present in a given set, and you can denote it with what? At least the empty what? The empty set. So now quickly, because sincerely we still have a long way to go, so quickly we can talk about what? Some other parts. So unit set. Unit set is when we have a single element. When we have a single element in a given set. In a given set. So example is, you can say set A contains what? So E there is what? Is a unit set, because it's just a single element. So let's talk about equality of sets or equal set. Equality of sets. Now, a set is said to be equal if they contain same elements, irrespective of what? Of the order. Let's say set a set is said to be equal. Is said to be equal if they contain same set of elements irrespective of the order of arrangement. So for example, I can say set A contains A, B, C, D, and set B might contain B, D, C, A. Now, we can actually say set A is equal to what? Is equal to set B. Are we together? We can say set A is what? Is equal to set B. Now, let's talk about what? Power set. So, let's talk about power set. Power set entails all the possible subsets that can be gotten from a given set. Example, let's say set A contains A, B, C. Let's say set P contains what? A, B, C. Now, to find the power of this set, find the power of this set. To find the power, the formula is what? The formula is 2 raised power n, where n is what? N is the number of elements in a given set. So now, how many number of elements do we have here in set P? 1, 2, 3. That's what? 1, 2, 3. That's the number of elements here is 3. So we'll say 2 raised power n. That's what? 2 raised power 3. And 2 raised power 3, we say is what? 2 times 2 times 2, which is equals to what? Which is equals to 8. Which means that in this case, there are 8 possible subsets in this, and let's list them. There are 8 possible subsets in what? In set P that can be derived from what? From set P. First thing first, the first possible subset is what? Is empty set. That's when there's nothing in this what? In set P. So the second one, we can singly fill them. So set A, set B, set C. Are we together? So we can singly fill them like that. Then we can pair them again, A and B. So when A and B are there, so when A and C are there, so when B and C are there, are we together? So then when 3 of them are there, A, B, C. Let's count. If it's up to what? 8. 1, 2, 3, 4, 5, 6, 7, 8. So which means that what? Those are the 8 possible subsets that can be derived from this given set P. Are we together? So that is that about that. So let's talk about what? 6. Let's talk about universal sets. It is treated what? Is treated like a parent set, often likened to subset also. So where all other given sets derive their elements. Now, I'm just saying this in what? In a very simplest term. It's not as though if you check textbook, this is what it will give you, but this is what it implies. Are we together? So now, a universal set is denoted with this or denoted with this. Are we together? So now, let's take for example, I said earlier that it's more or less acts often like what? Like a subset. So universal set contains 1 to 10. Then set A contains what? Even numbers between 1 and 10. Now, you can say that what? Set A is what? Is a subset of what? Of the universal set. Because all the elements in A you can find in what? You can find in what? In the universal set. So you can find in the universal set. So now let's talk about let's talk about complement of a set. Complement of a set. Now, complement of a set are sets of what? Of elements found in the universal set, but not in the given set. Are we together? So complement of a set are sets of elements found in the universal set, but not in the given set. A typical example is this. Let's say universal set contains what? 1 to 10. We'll still use that. And set A contains what? Prime numbers between 1 and 10. Now, they now said we should find a complement. We can write it as this or a complement. Are we together? So now, to write this out, I can say that it's simply, first thing first, let's list out the set of elements in elements. We are given this in words. I said earlier that we can give it in what? Set builders or set notation, but then we're still going to that. Now, 2 is a prime number, 3, 5, 7. So those are the prime numbers between 1 and what? And 10. So a complement means what? Elements in universal sets that are not in what? That are not in A. Now, which elements are not in A but are in universal set? 1. Which elements are not in what? A but are in the universal set? 2, 3, 4. 4 is not there. 5 is there. 6 is not there. 7 is there. 8 is not there. 9 is not there. 10 is not there. So these are what? The complement of what? Of this set A. Now, let's talk about what? Cardinality of set. Cardinality of set. Cardinality of sets are possible number of elements in a given set. It is denoted as. So when you have this and they put question mark, it's telling you that what? They will not tell you find the number of how many number of elements are in this set. They will just tell you n into brackets A. So that's what? How many number of elements do we have in A? That's 1, 2, 3. Let's say, for example, A is what? 2, 3, 5, 7. Then I said find n of A. Are we together? You will just put 1, 2, 3, 4. The final answer is what? 4. So because those are what? The number of elements in that what? In that set. So if they ask you that a complement, you should find a possible number of elements in what? In a complement. So let's talk about what? Union and what? An intersection of sets. So that's where we'll finish set theory, then we move to Venn diagram. So union and intersection of sets. So now, union of sets union of sets is actually combining, or is the combination of the given element rather present in a given set. Combination of the elements present in what? In a given set. Are we together? Without repeating same elements in different sets. Now, what this English entails, I will explain it. What this English entails, I will actually what? Explain it. Now, let's say that we have union is denoted with what? Union is denoted with a symbol like a U. So now, let's say we have set A to be what? 2, 3, 5, 7. Then we have set B to be 4, 6, 8. Are we together? Then they said find A union B. A union B would be what? Bring them together. There is no check. Is there any repeated elements? No. Then bring them together. That's 2, 3, 4, 5, 6, 7, 8. So that's what? A union B. The second example, let's say set P contains what? A, B, C, D. And set M contains what? A, F, E, D. Now, and we are told to find P union M. Are we together? So here, check. A is common. P union M, we are going to represent A, just a single term. B, C, D is also common. We are going to represent it just a single term. Then we put E and what? And F. So that is what? The union of what? Of the given set. Possibly they said find a number of P union M, then you count 1, 2, 3, 4, 5, 6. Then you write 8. Don't make mistake of writing A twice and D twice, please. So now let's talk about what? Intersection of sets. Intersection of sets. Intersection of what? Of a set. Now, this is just listing out the common elements in given sets. So listing out the common elements in a given set. Let's take example 2 under union. So set P is what? A, B, C, D. And set M is what? A, F, E, D. Now, so intersection is denoted with this, just like an inverted U, so like N. So now, we now said find P intersection M, which means we are saying bring out what is common, just the common element, and you write them once. A is common, D is what? Is common. Are we together? So that is P intersection M. P intersection M is what? A is common, you write them out. D is also what? Common. Because where I wrote it earlier is actually a blind spot. So that is what? Intersection. That is intersection. So now let's solve example. The example now will involve a set builder or set notation that I mentioned earlier. So that I can explain it. Example, universal set contains x is such that x is okay. X is such that 1 less than or equal to x less than or equal to 20, where x is an integer. Okay, and set A such that less than or equal to y okay. Okay, 20 y is a prime number. So, and b z is such that less than or equal to z, pardon, nineteen, z is an odd number. Okay, let me reduce this to 10. Are we together? So we said find 1. You can say that A intersection B. 2, we can say A union B. 3, we can say A. So now, finding the solution to this, the first thing we should do is what? Is listing out. Now, this is what? Set notation. Now, this is having what? Equal to, less than or equal to, which means that this thing are integers. X is an integer, and it should start from 1 and end in what? In 20. That's what it implies. Why? Which means that what? 1 is not inclusive and 20 is not inclusive. So prime number between what? 1 and 20. So this says that 1 is inclusive and what? 10 is not inclusive. It shows that what? Z is an what? Odd number, which means odd number from 1 to 10. Do we understand? But 10 is not what? It's not an odd number. So now we just quickly list it out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That's what it means. So A, so that's what? That's 2, 3, 5, 7, 11, 13, 17, and 19. So those are what? Prime numbers between what? 1 and 20. So B says that what? That we'll have what? Odd numbers from 1. 2 is not an odd number. 3, 5, 7, 9. So those are what? The odd numbers. Now, the first question says we should what? We should find A intersection what? Intersection B. What is common in A and is also common in B? So that's what? 3, 5, 7. That solve it. Now 3, 5, 7. That solve it. Now second question. So he said we should find A union B. Are we getting it? We will not repeat the common ones. Are we together? So we won't repeat the common ones. 1, 2, 3, 5, 7, 9. So we've expanded this. So that's what? 11, 13, 17, and 19. Are we together? So that is it. Then number 3, then we can say that 3 is what? A union B complement. That is, what is in reverse set that is not in A union B? So A union B all complement. So then we say that 4, 6, 8, 10, 12, 14, 15, 16, 18, and 20 are complement of what? A union B, because they can be found in universe set and cannot be found in what? A union B. Our next question is what? A prime intersection B. So A prime are what? What is in the universe sets that are not in A, and that's what? 1, 4, 6, 8, 9, 10, 12, 14, 15, 16, so 18, and what? And 20. So then A prime intersection B will be what? What is in A prime and is also in B? That's 1 and what? And 9. So then the last one, he said we should find what? We should find number of what? A intersection B, which is what? 1, 2, 3. So this is where we stop in our set theory. Our next video, we're watching what? We're explaining Venn diagram. Please like, share, and subscribe